last section of it. We are down here on horizontal asymptotes. Just as a reminder, we did this problem yesterday at the end of the period. I made this problem up, and we talked about different things like the zeros. The first thing we talked about was zeros or x-intercepts. Shh. To find x-intercepts, you plug 0 in for y. And when you do that, it will always be the case that you multiply the bottom over to the other side, right? And the bottom cancels. So it's really finding the zeros, if you want to put a little note, is like setting the numerator equal to 0 and solving, right? Because the bottom is going to cancel when you multiply it over. When you're looking for the VAs, the vertical asymptotes, you set the denominator equal to 0. Okay? But sometimes a VA will actually be a whole. When is it a whole instead? When they cancel out. So like this top factor down is the difference of squares, x plus 2, x minus 2. The bottom was x plus 7, x minus 2, and the x minus 2 is canceled. So that means 2 is actually a whole, and the x plus 7 or negative 7 was a VA, right?
That's a lot of x plus 7.
That's a lot going on there, right? Okay? Shall we do another example of that before we move on? Do we need another VAHA example before, or VA whole example before we move on?
Can you give us a little one?
A little one? I'll make it small. We won't do the zeros. Actually, we could do the zeros. Y equals, let's do x minus 3 over x squared plus 9. Okay, let's do that one. Write this down in the bottom right corner of your note sheet, and let's do it. X minus 3 over x squared plus, no, x squared minus 9. I need to fix that. Minus 9.
No, but I'm pretty sure major and
Okay. Write this in the bottom corner. Zeros, VAs, and wholes is what we're looking for.
What number are we on?
This is, I just made this up.
There's a whole at positive 3.
you're lost.
Yeah.
What page are we on
I put this in the bottom corner of your note sheet somewhere.
How was the whole positive?
Okay, zeros. How do you find zeros?
I don't know.
Plug 0 in for y.
Y equals
Then what?
Both of whole, it's 3.
Multiply the x minus 9 over times x squared minus 9.
Still 0.
Okay.
Still 3.
He's gone. X minus 3 equals 0, so x equals 3. That is where my 0 is. That's my x-intercept is at 3. Okay? VAs. How do you find a VA?
Plug 0 into the bottom.
Nope. Kinda.
Va.
VA is set the denominator equal to 0. So x squared minus 9 equals 0. Okay, but he breaks down, he's a difference of squares. He is x plus 3 and x minus 3. If I set x plus 3 and x minus 3 equal to 0, x equals negative 3 and x equals positive 3. Okay, one of those is a VA, one of those is not a VA. Okay, now it's kind of tricky to know which one is a VA and which one's not a VA. Here, if I broke him down, was x plus 3, x minus 3. Right?
Oh, wait,
which one cancels out?
The negative.
X minus 3 cancels out. So which one is a whole? Positive 3. This guy is my whole, right? This guy is the VA. Does that make sense? It's kind of confusing. X minus 3 was the one that canceled. So that means x equals positive 3 is the whole. Yeah? That's how that works. Okay? Wholes and VAs. What?
Zeros and wholes be the same?
Not always. Well, yeah. Your 0 will appear as a whole. Your 0 will always appear as a whole. Okay, good? All right. Next thing, we have horizontal asymptotes, which are the ones that go left and right. And yeah, so like most of these functions, these boomerangy equations have a vertical asymptote, and then they also will have a horizontal asymptote. Now, common misconception. A lot of people think that if you have a horizontal asymptote, it means you cannot cross your horizontal asymptote, and that is false. Okay? Let me show you what sometimes happens, and a lot of people don't like, this doesn't make sense to them. Here's my horizontal asymptote. Let's say I have a function that does one of these. Let's say it does this. Okay? It's a horizontal asymptote because as that goes forever to the right, it is leveling off at this point, but it does cross right there. Okay, so when you're talking horizontal asymptote, it doesn't mean it can't cross at that point. It just means as you go forever to the left and to the right, it will level off at that dotted line. Does that make sense? Okay? So he can cross. A lot of people don't understand that. Okay?
So
It's not that he can't cross it. It's just as he goes forever to the right and to the left, he will level off at that dotted line. Got it?
So a ha can cross.
Okay, you can cross that place at a ha. Here is how you find the ha. There are 3 rules to it. And it has to do with, go to the top of the next page. It has to do with N and M. Okay, write this down. Top of the next page. We are on this part. Horizontal asymptotes. These are the rules. Rules for, yeah, we did. Rules for horizontal asymptotes. N is the degree of the numerator. M is the degree of the denominator. Okay? Degree of the numerator, degree of the denominator. Degree meaning highest power, right? Okay, here are the rules. Number 1, if N is bigger than M, meaning like if you have x to the second power over x to the first power, your N is 2, your M is 1. If N is greater than M, he is going to fall over, right? Because he's top heavy. Things that are top heavy fall over, which means he will have no ha, right? If he's top heavy, he will fall over and he will have no horizontal asymptote. That's how you remember that.
No ha.
He has no horizontal asymptote. What?
Oh,
These are from yesterday. So, if your N is bigger than your M, if your highest power on top is bigger than your bottom, he's gonna fall over and there will be no ha. I'm gonna go down to number 3. If your N is smaller than your M, like if it's x over x to the second power,
Oh,
N is 1,
That's 2.
M is 2.
You're wrong, Tommy.
Oh, wrong. They always put them in that order anyway. Okay, number 2. If he's like x to the first power over x to the second power, he's bottom heavy. So he's gonna stand up straight, but he's not gonna go anywhere. He's just y equals 0 because he's bottom heavy. So he's just gonna sit there at y equals 0. Got it? Top heavy falls over, no ha. Bottom heavy, he just sits there at y equals 0. Okay? Now, if N is equal to M, like as in x to the second power over x to the second power, right? You look at I call it y equals LC over LC, and LC stands for leading coefficient, okay? So this one's kind of boring. What's the leading number in front of x squared?
1.
1. What's this leading number?
1.
1. So in this case, y would be 1 over 1, or y equals 1 is my ha, okay? It's a little bit more exciting if you have like 2x cubed over, let's say, 5x cubed. What would my ha be then? 2/5, right? Okay? It's just the leading coefficients. If they are exactly the same, you take the number out in front and that's what your ha will be at. Okay? Good? All right, let's do that.
Is that,
Those are my 3 rules. What?
that as simple as it gets?
That's as simple as it gets. Ha's are easy. Ha's are easy. You don't have to do any computations or anything like that, okay? Now, you do have to be careful because sometimes they will put these in the wrong order. I don't think any of these are. Like this one is the degree, this one's the degree. So for A, N is 2, M is 4. Okay? 2 is smaller than 4, so he is
0.
bottom heavy, right? He's bottom heavy, so y equals 0 is going to be my ha. Okay? Now, do you know what it means when I say y equals 0 is my ha?
That's where he's approaching.
He's right here. Like at 0. My horizontal line is at 0. He's not moving, right? He's bottom heavy. He's going to sit there. Okay? Part B. What's N?
3.
3. M is 2. He's top heavy. So what happens? He falls over and none. There is no ha. He will not have a horizontal line that he will conform to on either side, right?
Does that
We
mean
have
he'll
N
just be
equals
moving the whole
2
time?
over
Yeah.
N
Both
equals
ways?
2.
Yeah.
You want to just
He will, what he'll do is he'll be like a polynomial where he's going to go like this and like this. He's not going to like conform to one side or the other.
Is C 8
Like he's
over
not
2?
going to level out at one number. He's going to continue to go to infinity or go to negative infinity. Something like that. That's what he will end up doing. Okay?
Go that extra.
All right. C. What is N?
8 over 2. 4.
2. M is also 2. We're looking at our degrees. So we do the leading coefficient, which is 8 over 2. So my ha is at 4. And what that means is that 1, 2, 3, 4. There's where my ha is. So my boomerangy things might go like this. I don't know. But that's where he is horizontally. Got it?
I can do this. This makes
Yeah, not too bad, right? That's how you find your hop.
Wait.
No math computation. What?
Why would they be boomerangs?
I don't know. I'm just saying. Like,
Oh,
that's
you're
what he
just-
might look
okay.
like. Yeah, that's what
Sorry.
he might look like. Whatever.
Got
Okay? Good? Happy with that?
I gotcha.
All right, let's go to the next one.
So what if there's no degrees?
What?
Like what if there's no degrees and then
Then it's series.
like no degrees over
Oh,
x to
like
the
let's say
fourth?
he's like 1 over x to the 4th.
Sure.
What's your n?
0.
This is x to the what power?
0.
0. Yeah. So your n is 0, your m is 2.
So
Yep.
it's
Or his
always-
m is 4, I mean.
So it's always 0.
Yeah. So it's always 0 if it's just a constant in the top. Good question. Okay. All right. This one. This is one where the graph is going to cross the horizontal asymptote. So like, let's say my graph is here and I have a horizontal line here at like, let's say 2, right? And my function is going up and then it's leveling off like that, right? Okay. He is crossing. He is going to cross that horizontal asymptote, but he's leveling off as he goes forever to the right. They want us to find the ha first and then figure out where he crosses. Okay. So this guy, we have to figure out n and m. What's the n value?
This is
Oh, we already did this one.
it's 4.
N was 2, m was also 2. Those are my degrees, 2 and 2.
4.
So y equals 8 over 2, which is 4. Okay, now how do I figure out, if my horizontal asymptote's up here at 4, how do I figure out where he's going to cross that?
You plug 4 into the power y.
I plug 4 in for y. I want to know where the y coordinate is 4, right? On my
You said
graph,
it
I want to know
equals
where the
4.
y coordinate's 4, so I plug 4 in here. Does that make sense?
You said it equal, right?
We're going to set it equal to 4. Yep. So 4 is going to go in this spot right here. Okay, so we got a little bit of work to do. 4 equals 8x squared plus 9x minus 5 all over 2x squared plus 1. Okay, now what do I do?
Multiply the bottom.
Multiply the what? The bottom over. Okay, 2x squared plus 1 times 2x squared plus 1.
Foil that out real quick.
Yep, so if I FOIL the 4 through,
16x.
wait a second, what?
8x.
8x squared plus 4? Oh man, this is so nice. Oh, they were so nice to you.
They were
Oh my gosh, they were so nice. Look at that.
Wow.
Okay, now what?
We can just
Should we move all this stuff over to the other side?
8x squared.
Minus the 8x squared. So it
Minus the 4.
goes away. And minus the
Add
4 also?
5. No, add the 5.
No. Oh, wait. Actually, yes. So
That's what I did.
really
I
quick.
added it the other way.
the 8x squared is going to go away. So you have 4 equals 9x minus 5. Typically, I want to get everything to one side if I'm dealing with a quadratic function. But now I don't have quadratics anymore because the 8's are gone, right? So I just want to get the x by itself. So I'm going to leave the 9x on the one side and add the 5 over. So 9x equals 9 and x equals 1. So hey, my graph doesn't look too terribly bad. Up here at 4 is where x is 1. So at 1 comma 4 is where he's touching that horizontal asymptote. Okay? And there's not a hole there. Like he actually has a legit value at that point. But he's just leveling off on the right side the further he goes out. Got it? Does that make sense? Ish. Okay? Good? All right, last thing. These are not going to be your favorite, but it's fine. These are something called a slant asymptote, okay? All right. So you have vertical asymptotes. These are what like these look like. That's a va, okay? Then you have ha's, which go this direction. Then you have slant asymptotes, which are linear functions, and they might look like this, okay? So you might have a slant asymptote in combination with a vertical asymptote, and your function looks like this. That's what he looks like. He's like hyperbolas. Have you heard the word hyperbola before? That's what he is, okay? So I have a slanted one instead of a horizontal one, and he looks like that, right? It's like my L's have been like smushed. My boomerangy things have been kind of smushed, okay? Now, here's when you will have a slant asymptote. Write this down because I don't think they have it. Oh, no, they do right here. But I'm going to write it down here below. A slant asymptote will occur if n equals 1 larger than m. Okay? If n is 1 larger than m, for example, if I have, like, let's say x squared plus 3x plus 6 over
So
x
basically,
minus 1.
if they don't
okay?
have a ha, they have
If he doesn't have a ha,
depending
he will have a slant except for,
when they're
okay, so this guy's top heavy, right? N is 2, m is 1, he's the first degree on the bottom. So he's top heavy, so he's gonna fall over, he's not gonna have a ha, okay? This guy will have a slant because 2 is 1 larger than 1, right? Now, when will he not have a slant or a ha?
if it's x to the fourth over x.
Like x to the fourth over x squared, right? Okay? If it's x to the fourth, n is 2, or n is 4, x squared on the bottom, m is 2, and then they're 2 apart from one another, so you won't have a ha because he'll fall over, or you won't have a slant, right? You'll just have a va in that case. Got it? Okay, so that's when a slant will occur, and here's how you find the slant. Ready, set, go. I left you a lot of room on example 6 because we need it. Here we go. Here's how you find the slant asymptote.
Is this an equation you've given us? What are you doing?
Oh,
Synthetic
I
division.
know.
You can use synthetic division. I'm just going to do long division.
You're kidding, right?
Yeah, I would do long division always.
Always?
Yeah, I would do long division
No,
always.
there's sometimes where you can use.
I mean, you can do synthetic in this case, but whatever.
Can you just
It's fine.
do 2
I don't
divided
remember
by
when.
all of that?
Okay, we'll just do long division. Let's just do long division. What do you take times x to get 2x squared?
2x.
2x, he goes on the top. Now multiply him back through. 2x squared, 2x times negative 2, minus 4x. Then you switch the signs, minus plus. That's gone. Okay, how many x's do you have? Negative 1x. Drop the 3 down, minus 3. What do you take times x to get negative 1x?
1.
Negative 1. Negative 1 times x is negative 1x. Negative 1 times negative 2? Plus 2. Then I
2.
switch the signs. So plus, minus. And what's the remainder? Negative 5. Okay? So he will be minus 5 over x minus 2. That's what my long division result is. Got it? Okay? Now, does that make sense? Here's how it relates to a slant asymptote. Ready? A slant asymptote is a line like this one right here. Whoop. A slant asymptote is a linear function. Is a linear function, right? Your slant asymptote will be y equals 2x minus 1. It is everything except the remainder, so you don't even have to worry about what the remainder number is. I don't really even care. Y equals 2x minus 1. Do you know how to graph it? Start at negative 1, up 2 over 1. That's my slant asymptote. Now, why does your n have to be 1 larger than your m?
Otherwise you won't reach.
Because when you divide them, it has to be linear, right? In order to be a straight line. Make sense? Okay, otherwise it wouldn't be a linear function. If n is 1 larger than m, it's going to be a linear function when you divide. Confused?
Yeah.
You're like, I don't really care. Whatever. Anyway, okay, so y equals 2x minus 1. That is your slant asymptote. Got it?
There's only 1.
What?
There's like have 2.
What?
Are we supposed to have 2?
No. This one says determine the asymptotes. So we found the slant asymptote
No, I
is y equals 2x minus 1. Let's talk about ha's. Will this guy have a ha? Not if he has a slant, right? If they were to look at ha's, we look at n and m. He's going to be top heavy, so he's going to fall over. So he doesn't have a ha. Will he have a va? How do you find the va?
X equals
The denominator equal to 0. So x minus 2 equals 0. So the va is at 2. So I have a va and a slant, but no ha.
Okay, so
Make sense?
grow up.
Yep.
Don't you have 2 on that picture?
2 what?
Or
Yeah, it's a bar.
No, it's a.
This one's a va and a slant, but not a ha.
so do you always have to have a va and a slant?
Usually you will have a slant. Yeah, you'll have to have a slant, a va with a slant, right? Because you have to have something to divide by, right? And if your denominator is where you get your va from, you will always have a
Okay.
So if you have a slant, you have to have a va, but
Yeah.
not if you have a va, you don't have to have a slant.
true. Yes.
Got it.
Yeah.
It's like a.
Yeah.
Could you have a
Yeah.
square
Where's a
and
rectangle?
a
So a
slant?
rectangle.
What? No, ha's and slants don't happen together. You can't have a ha and a
Could
slant.
you draw?
No.
Like even mathematically it doesn't work out. Can you still draw it?
Well, I mean, you can, but it's not going to be a thing.
Is that all we're doing? Or are we doing the last problem? We don't want to.
Do you know why you can't have a ha and a slant? I just thought of this. Ready? Here's my function. You tell me. Here's my ha, and here's a slant. Whoop, slant. Okay, so let's say here's where my function goes, and here's where my function goes. Why does that not work, but the other one does? Why can't you have a ha and a slant?
Because he goes like that. He's on this side.
You're warm.
What is that?
It's not a function.
Yeah,
Does it
that's
pass
what I
the
was
vertical
gonna
line
say.
test?
Yeah.
But if you have a va and a slant, it will pass the vertical line test. But if you have a ha and a slant, it won't.
That's the same thing as like you can't have like a
Yeah,
side function.
yeah, right, exactly. Yeah, yep. Okay, there you go. That was beyond what you needed to know. But anyway. Okay, let's skip example 7. Slant asymptote, everything except the remainder. There you go. We're done with 2-5.
Wait.
Bleh.
Did we skip the last
So for
Yeah.
slanted, you can use synthetic, but for nonlinear, you can't. Yes. Right?
I don't ask you any of them.
Yeah, I have a question. It says if the graph of the function has a horizontal asymptote, determine the point, if any, where the graph crosses the horizontal
Okay,
asymptote.
so did you find
That's
the ha?
what we did.
I found the ha. There
Now
is no
plug that
ha.
number in for y. Oh, there is no ha?
I don't think so.
What number are you on?
36. 36 of the half.
Y equals 0.
Yeah.
Okay, so now you plug 0 in for y. Because I want to know where it touches 0, right? Kind of like before we
But if
did
you
where
go
it
with
touches
eight,
But
4.
if you do that, it means 0 equals 8, so it doesn't cross 0 equals 8.
Okay, so it won't cross then.
Okay.
So he'll have a ha, but he won't cross the ha. Yeah. Okay, that was a lot. Whew. Okay, I'm gonna stop recording.